I stood under the silent night sky, binoculars trembling in my hand, when suddenly everything changed. A ghost from outside our solar system was heading this way. Not just another comet, but an interstellar wanderer, 3I Atlas, hurtling toward the sun and then past Earth's domain. It carries with it the secrets of another star, perhaps even a different galaxy, and with each passing moment, its story unfolds right above us. Imagine a frozen relic, born around another star billions of years ago, now crossing billions of kilometers to visit our cosmic neighborhood. What would it feel like if we realized that the sky we know is being intruded upon by a visitor so foreign, it rewrites our sense of belonging? And then the shock. Although early reports spurred excitement about a close Earth approach, the data tells a quieter truth. 3I Atlas will not swoop near our planet after all. That revelation flips our anticipation into reflection. The visitor is magnificent. Yes, but it won't touch us. Yet the fact that it can traverse the solar system, stemming from another world entirely, throws open a question. What does its presence mean for us? So here we are, at the cusp of a cosmic moment. An interstellar object unbound, intruding our solar sphere, invisible to the naked eye yet huge in implication. What we assumed about our isolation, about our skies, begins to wobble. And so I ask you, when a visitor from another star system glides past, what does that tell us about ourselves, our origin, our future, our place in the universe? As the comet shifts across constellations, as telescopes trace its tail and chemistry, we're about to descend deeper into its story. Because if 3I Atlas is here briefly, then maybe the universe is far less isolated and far more interconnected than we ever dared imagine. When astronomers first caught sight of it in April 2024, the data didn't quite make sense. The object cataloged as A2024H3 Atlas seemed ordinary at first, a faint, slow-moving dot among millions. But then, subtle discrepancies emerged. Its orbital eccentricity wasn't just high, it exceeded 1. That single number whispered the impossible. This was not a solar system body looping around the sun. This was something from beyond. Soon, the designation changed, from A to 3I, marking it as only the third confirmed interstellar object ever detected after Oumuamua in 2017 and 2I Borisov in 2019. Unlike its predecessors, though, 3I Atlas is active. It's shedding material, forming a visible coma and a tail, and glowing with volatile elements that haven't seen sunlight since another star's infancy. Its inbound speed, roughly 26 kilometers per second relative to the sun, fast enough to escape not only our gravity, but every gravitational tether in the solar system. It is a messenger on a straight trajectory through our celestial neighborhood, arcing briefly inward before slipping back into the galactic dark. Telescopes like Pan-STARRS, Gemini North, and JWST's NIR SPEC have turned their gaze toward it, analyzing the faint spectral fingerprints from its coma. The early readings revealed something astonishing. The ratio of carbon monoxide to water in 3I Atlas doesn't match anything we've measured in solar comets. It's richer in exotic volatiles, suggesting formation in a region colder and perhaps older than our own protoplanetary disk ever was. Its trajectory tells an even deeper story. Extrapolations trace its path backward into the galactic plane, possibly from a stellar nursery near the constellation Lyra, though uncertainties remain vast. What matters is what that motion implies. 3I Atlas isn't just a frozen rock, it's a sample from another system entirely. A natural probe, unintentional yet invaluable, carrying within it the isotopic memories of a distant sun. For planetary scientists, this comet is a time capsule. For astrophysicists, it's a statistical miracle. The odds of even detecting 3 interstellar interlopers within a decade are minuscule. And yet, here it is, cutting across our skies with a grace that defies borders. Its visit will be brief, just months within observational range, but the data collected during that time will redefine how we model planetary formation. Because if 3I Atlas carries organics or molecular ratios that diverge sharply from ours, it challenges the comforting idea that our solar chemistry is universal. The closer we look, the more its foreignness speaks. Even the dust it releases is slightly darker, hinting at cosmic radiation exposure over millions of years adrift between stars. Each grain is a page in a story written before the sun was born. And so, as we watch it glide through the void, one question rises like a shadow at the edge of the data. If objects like 3I Atlas are moving through interstellar space all the time, how many have already passed us unseen, whispering through the darkness without ever being noticed? For centuries, we believed our solar system was a self-contained arena, a gravitational island wrapped in the calm of space. Comets, asteroids, planets, all tracing their elegant ellipses around the sun like clockwork. Predictable, familiar, closed. That illusion shattered with one tiny dot of light. When astronomers confirmed the interstellar velocity of 3I Atlas, it wasn't just another discovery. It was a confession that our cosmic borders are porous. The solar system, it turns out, isn't a fortress. It's a train station, with travelers constantly arriving and departing, most unseen, each carrying stories from the infinite beyond. We had hints before. Oumuamua's elongated shadow slicing through the inner system in 2017, Borisov's luminous blue coma in 2019, but those were glimpses, the kind that leave you wondering whether you just imagined it. 3I Atlas, however, feels different. It's active, it's traceable, and it's alive in its chemistry. It makes the abstract idea of interstellar exchange tangible, right there, in the glint of dust particles scattering sunlight, in the faint carbon monoxide lines flickering in a telescope's data feed. And that's where the illusion breaks most powerfully, the line between ours and theirs. We once mapped the solar system like a territory, defining where the sun's influence ends, where the Oort cloud thins, where interstellar space begins. But nature doesn't respect those cartographic boundaries. 3I Atlas crossed them effortlessly, like wind crossing a border that only we imagined. It's humbling, because if one comet can wander in from another star, it means the building blocks of every world, hydrogen, carbon, silicates, ices, are not exclusive to us. They travel, migrate, mix. Every planetary system is just one swirl in a much larger galactic current. Maybe some of Earth's own atoms were once passengers like this, drifting through space long before finding a home under our sun. And maybe, somewhere out there, fragments of us are already leaving, cast out from comets ejected by Jupiter's pull, on their way to another civilization's sky. That realization unsettles the human mind because it erodes a comforting story, that we are contained, special, isolated. 3I Atlas doesn't come to harm or to bless. It comes to remind us that the walls we imagine around our world are illusions of scale. The universe is an open system. Materials, energies, even stories flowing endlessly between stars. Some astronomers now whisper a provocative thought. If these objects are common, then every star might be constantly trading material with its neighbors, a galactic ecosystem, invisible yet alive. And if that's true, then what we call our solar system might just be a temporary arrangement in an infinite migration of matter. The illusion of cosmic separation fades, replaced by a quieter, stranger thought that begins to take shape in the back of the mind. If interstellar comets can travel between worlds carrying the fingerprints of life's chemistry, could they also carry the seeds of life itself? The story of 3I Atlas didn't begin in wonder. It began in noise. Tiny flickers in the Atlas survey data, points of light that didn't quite behave like any known comet. At first, the team thought it was a processing error, a glitch in motion tracking. But when independent observatories picked up the same trace, the investigation deepened. First rung, observation. The Pan-STARRS telescope on Haleakala confirmed a moving object with an eccentricity of 1.02, just above the threshold that defines escape velocity from the sun's grip. That single metric meant one thing: this visitor was unbound. Follow-up images revealed a diffuse tail forming unusually early, suggesting a volatile-rich nucleus that began sublimating far from the sun. For planetary scientists, that's a red flag, or rather a neon signature. Only interstellar ices exposed to cosmic radiation for millions of years behave like that. Second rung, pattern. Spectroscopic data from the Gemini North Telescope showed a chemical fingerprint never before recorded in any solar comet. The ratio of CO to H2O was off the charts, far exceeding even 2I Borisov's exotic chemistry. It hinted that 3I Atlas formed in an environment colder than our outermost Oort cloud, perhaps in the frozen cradle of a red dwarf's debris field, where sunlight barely touches the dust. The spectral slope also showed an unusual deep blue tint, suggesting dust grains coated with organic tholins, complex molecules that can form under ultraviolet radiation in interstellar space. Third rung, hypothesis. Astrobiologists began to ask the daring question aloud. If 3I Atlas contains complex organics, could interstellar comets be vectors, carriers of prebiotic material between stars? The idea, known as panspermia, has hovered at the edges of scientific respectability for decades. But with each interstellar visitor, it gains new credibility. Oumuamua gave us mystery. Borisov gave us activity. Atlas gives us chemistry. The chain of evidence grows. Fourth rung, implication. If organic compounds can survive millions of years in deep space, shielded within these icy fragments, then life's ingredients may not just emerge locally, they might travel. They could be spread like spores across the galaxy, seeding potential worlds when conditions align. In a sense, 3I Atlas might be a messenger from a distant system, or even a fragment of the same cosmic process that gave rise to us. Laboratory analysis of its light shows carbon-based molecules, possibly simple amino acid precursors. The data is still early, but the signal is clear enough to make researchers pause, because that means that our solar chemistry, and perhaps our biology, might not be unique at all. The same molecular alphabet could be scattered across the Milky Way, recombining under alien suns, rewriting itself in infinite variations. And somewhere between those spectral lines and silicate signatures lies a quiet question that grows heavier with every observation. If life's chemistry is written everywhere, maybe what's rare isn't the origin of life, but the recognition of it. When we speak about 3I Atlas, we're not merely describing a comet. We're describing a memory, a fragment of another world crossing ours. Its atoms have journeyed longer than all of human history combined. Its dust may predate our sun, and in its silence, it forces us to ask, what if we are not local beings, but cosmic inheritors of matter shared across the galaxy? The thought sounds poetic, but the data makes it plausible. The carbon chains shimmering in its spectrum resemble those found in interstellar clouds, the same chemistry that would one day shape DNA, RNA, and the metabolic molecules inside every cell of life on Earth. If that chemistry truly migrates between stars, then life might not be a planetary event at all. It might be a galactic inevitability. That idea shakes something at the core of our scientific identity. For generations, we've seen ourselves as products of a single solar system, an isolated evolutionary story sculpted by one sun, one Earth, one chance. But 3I Atlas suggests another narrative, that life in all its forms may be continuity rather than coincidence, that the universe is not a void but a bridge, a circulation of matter and memory. Still, skepticism remains. Many astrophysicists remind us, the detection of organic molecules doesn't mean life. It only means potential. Molecules can form abiotically. Carbon can mimic biology's signature without ever breathing. The philosophical tremor then lies not in certainty, but in possibility. Because if even one comet carries amino acids or their precursors, then every planetary system it passes could inherit the chance, the permission, to begin life anew. There's another layer here, quieter, but no less profound. When we look at an interstellar object like 3I Atlas, we are, in a sense, witnessing our own reflection. We are made of the same itinerant material, forged in stars, ejected, recycled, reassembled. The comet's journey across systems mirrors our own intellectual journey across eras of understanding. It shows us that curiosity, too, is a kind of migration, the mind traveling across unknowns. And if that's true, then our cosmic loneliness has always been an illusion born of short timescales. On galactic terms, matter mingles, stars share, systems trade. Perhaps consciousness itself is the galaxy remembering itself in fragments, a distributed awareness waking up piece by piece across the stars. 3I Atlas doesn't claim to answer that. It only gestures toward it. Yet in that gesture lies a whisper that refuses to fade. If life began everywhere, then existence is not local, it's universal. And maybe, just maybe, we've been searching for others not to find something foreign, but to rediscover what we already are, part of a much larger mind, written in dust and light. Every discovery like this leaves a trail, not just of dust, but of ambition. When 3I Atlas flashed across our detectors, it reignited a conversation that had been quietly building since Oumuamua. What if we could catch one? Until now, interstellar visitors have come and gone too quickly for us to reach them. Their velocities, tens of kilometers per second, make interception nearly impossible with our current propulsion systems. But that's starting to change. In laboratories from NASA's Jet Propulsion Lab, To the European Space Agency's Concurrent Design Facility, engineers are sketching blueprints for a new kind of mission, an interstellar interceptor. Its goal? To stand ready, dormant in orbit, fueled and waiting, for the next alien traveler to appear, and then launch in time to meet it. The European Space Agency already has plans underway. Their mission, Comet Interceptor, originally designed for an untouched solar system comet, could, if fortune allows, be redirected toward an interstellar object like 3I Atlas. Imagine that, a spacecraft intercepting a visitor from another star, sampling dust and ice that have never known our sun. The data from such a rendezvous could answer questions that have haunted us for decades, about the origins of organic material, the diversity of planetary systems, and the very chemical uniformity of the Milky Way. But beyond the technical allure lies a deeper horizon, one that belongs to philosophy as much as to engineering. Because each interstellar visitor reminds us that we're no longer passive observers. Humanity has reached the stage where we can notice these messengers, track them, analyze them, and soon, chase them. For the first time, our curiosity is catching up with the speed of the universe itself. It's easy to imagine a future where interstellar interception becomes routine. Small probes slingshotting through the solar system to intercept foreign comets, extract data, maybe even return samples. And when that happens, the boundary between us and them will blur even further. Our telescopes will no longer just watch the galaxy. They'll participate in it. 3I Atlas may be uncatchable this time, but its arrival has already rewritten our technological trajectory. It's teaching us to prepare, to be agile, to think in terms of galactic rather than planetary timescales. The next object might be closer, slower, or stranger. And somewhere, deep in a control room, a mission planner will be ready, watching for the faint signature of movement against the stars. Because if 3I Atlas teaches us anything, it's that the universe doesn't wait. It sends its emissaries without warning, carrying stories in frozen silence. And the next one might not just pass by, it might linger. It might reveal structures or materials that force us to reconsider the boundaries of what natural even means. After all, if interstellar objects can traverse light years and remain intact, then perhaps there are others, older, darker, artificial, hidden in the same vast flow. It's strange how something so far away can make us feel so close to everything. 3I Atlas is hundreds of millions of kilometers distant, yet when you hear about it, when you see the composite images, the trail of light traced across space, something quiet stirs inside. A reminder that we are not merely in the universe. We are of it. That realization reshapes the ordinary. You walk outside at night, the same stars burning above you, and for a moment you remember that one of those invisible dots is being visited by a traveler from another sun. It's not science fiction. It's happening right now, silently. And that silence speaks louder than any broadcast could, because what 3I Atlas represents isn't just movement through space, it's continuity across time. It reminds us that the atoms making up our skin and blood once traveled between stars too, maybe as part of an ancient comet, maybe as dust drifting through a nebula, maybe as the cooled ashes of a supernova. We've been travelers far longer than we've been human. And now, as we watch this interstellar wanderer glide past, we're recognizing our reflection in it, the longing to explore, to connect, to carry meaning across vast distances. The beauty of it is that the data and the emotion don't cancel each other out. They merge. The same spectrum lines that excite astrophysicists, traces of carbon monoxide and cyanide radicals, are the same signals that tell poets and dreamers that the universe is chemically fluent in the language of life. Every photon reflected off 3I Atlas carries information, yes, but it also carries a kind of empathy. It says, you are not alone in your composition. The building blocks that made you exist everywhere. And that thought can change how we live. It softens the illusion of separation, between nations, between people, even between species. Because the moment we accept that the universe shares its ingredients freely, we can no longer pretend we are isolated creations. We are threads in a single galactic fabric, woven from the same dust that now drifts through the tail of a passing comet. In that light, 3I Atlas isn't just an astronomical event. It's a mirror for human consciousness, a reminder that our curiosity, our hunger to understand, is not random. It's the universe looking inward through us, trying to remember its own story. And as that icy traveler fades into the outer dark, It leaves us with a simple truth disguised as wonder. We have always been part of something much larger, something that moves through us as surely as we move through it. And maybe, someday, another civilization will look up at their sky and see a comet from our sun and feel the same small, trembling awe. Soon, 3Y Atlas will fade beyond the reach of our telescopes, a dwindling point of light swallowed by the same silence it came from. Its trajectory is fixed, its fate inevitable, to slip once more into the interstellar dark, carrying with it every unanswered question we projected onto its passage. But what lingers is not the comet itself. It's the shift it leaves behind. Because for the first time in human history, we can say this with certainty. We are not the only solar system whose fragments wander the void. The universe is not empty space. It's a web of exchanges, a slow dance of material and meaning across time. And each time one of these travelers passes us, we are reminded that we belong to that dance. It humbles and elevates at once, the realization that we're both observers and participants in something so immense that it transcends definition. Perhaps 3I Atlas is nothing more than a frozen relic, an inert chunk of ice and carbon, or perhaps hidden within it are the same molecular seeds that once drifted here billions of years ago to help awaken us. Either way, its story is ours, a story of movement, of transformation, of the infinite recycling of existence. So as this wanderer fades, the real question turns back to us. Are we ready to see ourselves as citizens of a shared cosmic ocean, bound not by origin, but by curiosity? Or do we still believe our skies end where our imagination stops? Do you think 3I Atlas is just a passing stranger, or a reminder that the universe has been whispering to us all along? Tell me below.